In this video, we're going to use a computer simulation model to investigate the qualitative relationship between voltage, current, and resistance. So we always use models to make things more visible. In this case, because we're looking at electricity, it can be tricky to play around with all the components and the wires and to feel like you can understand what's going on inside them. So this computer simulation simplifies that and makes the really key ingredients of the circuit really visible. So that's why we're using a computer simulation model. And a qualitative relationship. Now that's all about descriptions, the quality of the relationship. So we're not talking numbers, that would be quantitative. All we're talking about here is if I change voltage, what happens to these? Just in a descriptive way. So if voltage goes up, what happens to current and resistance? So we're going to investigate that kind of descriptive relationship using a model. So let's have a look at what our model looks like. So when you start off and you open up the model, this is what you see. So there are a few features here. We have V, this big V here represents voltage, and that is part of a mathematical relationship between voltage, I, which is current, and the big R, which is resistance. So we will be able to investigate in terms of an equation what happens when voltage changes or resistance changes. Other features, we have a little diagram here in this model, some batteries or cells end to end. We have a resistor represented by this red cylinder with dots on it. And we have arrows that show you the path of the current. We also have some numbers around here, and we're going to see the numbers change, but we're only going to describe them as getting bigger or smaller. And the last part of our computer model is this slider system here, which is going to allow us to be in control of changing the size of the voltage and the resistance. So let's get into it. We'll start off by reducing the voltage. So let's have a look at some of the changes that happen in the model when we move the slider down. I'll do that again. I'll reset it. Let's have a look what happens. Well, I've noticed a few things. Did you notice that the V here got smaller? And the I got smaller as well. Also, look what happened to our batteries. They got smaller. And the little arrows showing the current going around the circuit, they got smaller as well. So I'll reset it again. Let's have a look. Reducing the voltage. Look at the batteries decreasing. Look at the big blue V decreasing. Look at the red I decreasing. And look at the little arrows changing. You'll also have noticed that the number on the current ammeter reading here went down. So our qualitative description is that as voltage decreases, current decreases. Let's reset and see what happens as we push up the voltage. And you should probably be able to predict it now. If I push up the voltage, you see that V getting bigger. The I is getting bigger too. Number of batteries is increasing. And the arrows around the circuit are changing. So when you are labeling your diagram, you might be able to talk about an increase in voltage causes an increase in current. More batteries result in more current flowing around the circuit. That would be a qualitative relationship description. Let's go back to the beginning of our simulation by pressing the reset button. Now we're going to look at the relationship with resistance. So here is our dial for changing resistance. This is what we're going to be looking at. We're going to see what happens to current as we change R, and watch what's happening down here. This time keep your eye on the resistor, because that is what's going to change in the diagram. So let's start off by increasing resistance this time. There's the big R getting bigger and bigger. The I is getting smaller and smaller in the equation. Did you notice what was happening with the red cylinder? Let's reset, do it again. Watch the red cylinder. The resistance is going up by having more black dots. And did you notice what was happening to the arrows that show the movement of current around the circuit? They are decreasing. So our last thing to do when we're adding some labels to our diagram is look at when resistance gets smaller. Wow, there's lots to talk about there.